As Jack mentioned, this is Metabolic Classroom 2.0, and it's something that I have long missed from those days when this was coming to you weekly. I really enjoyed that. Part of my professional aspiration has been and still is this desire to take ideas that are really discovered in laboratories and find ways to share them with the public. Many of these ideas, when a neat discovery is made, it is published and it is in a peer-reviewed science journal behind a paywall, written in a scientific jargon that most people won't really appreciate and be able to understand. That's what this is then. The Metabolic Classroom is an opportunity to simply step over that hurdle and share the information directly with you, people who want to learn. And that's why I call it a classroom from here and forever on out. It's because I like the idea of me being your professor for a brief period of time. I'm teaching you these principles, and then you're able to remember them, understand them, and hopefully come to some lifestyle changes at the back end. Now, as Jack mentioned, the title for today is focusing on insulin resistance and the metabolic syndrome. And I could describe that another way, which is just kind of understanding metabolic health. And that's at the heart of what I wanted to focus on for the time that we have during the lesson itself. And again, please submit any questions. Nothing thrills a professor more than getting a lot of questions. So make sure that you get those in, and I am happy to address them as we have time. And we're going to have plenty of time. So get them in. All right. So first of all, metabolic health. We've all heard the term metabolism a lot. It is a buzzword. It is a word that we hear perhaps too often, and even to the point that it's often misused. Metabolism, just to be very precise, is the balance of all of the chemical reactions that are happening in the body. There are biochemical reactions in every cell that are trying to build up molecules. Those are called anabolic reactions or anabolism. And there are biochemical processes that are degrading molecules, breaking them down. That is catabolism. And metabolism is the fusion or the balance of all of those things, the sum of all of those reactions. Now, with metabolic health, now we're starting to get more specific to the topic. There are generally, in my mind, two ways that we can define metabolic health. Perhaps others may submit that there are other ways to interpret that term. Let's just stick with two. And I think this encompasses any real iteration that we would come up with metabolic health, any definition. So the first definition is simply defining metabolic health or explaining it looking at it through the lens of the metabolic syndrome. You've certainly heard of metabolic syndrome before. And it's nice to start with metabolic syndrome because that gives us some of the best statistics. As much as we're going to invoke and invite other ideas and principles throughout this lesson, unfortunately, they are a little more obscure to the point that there just isn't as much population or global level data. So if we start with the definition of metabolic health as some aspect of the metabolic syndrome, it helps us understand the scope of the problem, which is significant. The metabolic syndrome affects roughly half of all adults across the entire planet. That makes the metabolic syndrome the single most prevalent disease or health disorder in the world. That's why this topic matters so much. It's why I feel so justified and even gratified in having focused on metabolic health as a scientist for my profession, because it matters so much. The scope of the problem is so vast. Whether I'm giving a talk in Southeast Asia or in the Middle East or in South America, in every one of these areas and beyond, I know that this problem, metabolic syndrome, is the main health disorder that these people are experiencing. Now, what is the metabolic syndrome? You've certainly heard of it, but let's be very precise in identifying it insofar as metabolic syndrome is one way of defining metabolic health. Metabolic syndrome is a cluster of complications, in particular, 5 disorders that were noticed over the years to always clump together. They are, in no particular order, a bunch of highs and a low. So, high blood glucose. high waist circumference, high triglycerides, high blood pressure. Those are the highs, the 4 highs. And then lastly, the one low HDL. So let's just revisit those each very, very briefly. So the high glucose, that's no surprise. That's a sign of poor metabolic health. Your body's having a hard time clearing the glucose as you eat it, as you put it in your body. It's just lingering too long. And chronic hyperglycemia is pathogenic. It will certainly hurt the body. It can damage blood vessels and it can damage neurons and more. So that's important. High waist circumference, that evokes this idea of storing fat more centrally, particularly in the visceral space. And in future metabolic classrooms, we will revisit that topic, talking more about fat depots, where we store fat and why that matters. But more visceral fat is reflective of or contributes to higher inflammation and more general poor metabolic health. High triglycerides is a feature of the metabolic syndrome. That's the next one. And it is a very, very good predictor of heart disease risk. That's influenced by metabolic health. As the liver starts to suffer, it begins to overproduce triglycerides. At the same time, skipping one down, it starts to increase the clearance of HDL cholesterol, reducing HDL levels, considered to be the good or the beneficial version or carrier of cholesterol. And then lastly, it was the high blood pressure, which is directly related and a consequence, directly derivative of metabolic health. So those are the cluster of complications that make up the metabolic syndrome. Now, at first glance, those don't appear to have anything in common, that you can't see how they're related. But just like all the fingers of my hand that I was just acting up, all the fingers come from one hand, so too all of these complications of the metabolic syndrome come from or share one common point, which is insulin resistance. Insulin resistance is at the heart of the metabolic syndrome. In fact, so much so that what we call the metabolic syndrome used to be called the insulin resistance syndrome. That was, in its very first iteration, one of its earliest names. When it was first discovered that these problems tended to clump together, insulin resistance was known to be the mediating factor, or the thing connecting them all. I actually prefer that term. Would that we could go back in time and never change the name to the metabolic syndrome and keep it as insulin resistance syndrome. Now, I get it. Metabolic syndrome is a much more compelling name. It's going to attract much more attention, but it is also more vague. You can't hear the term metabolic syndrome and know what you could do about it. When you hear the term insulin resistance syndrome, then you could still identify all of those distinct disorders, each in their own, but acknowledge that there's one common variable. So let's address that one common variable, of course, namely the insulin resistance. So with that in mind, let me take a moment and define insulin resistance. This is something that we're going to talk about not only pretty heavily this month for the upcoming 3 metabolic classrooms through the rest of January, but this is also a topic that we will revisit a lot throughout this entire metabolic classroom forever. Every episode from time to time, you're going to hear me mention insulin resistance, whether it's indirectly or whether it is directly part of the topic as we go through chronic diseases. Insulin resistance is just that important. Again, the prevalence I've already mentioned, which is reflected in the prevalence of the metabolic syndrome, but it is so important because of its relevance, where every single chronic disease is in some way influenced by insulin resistance, where insulin resistance is either directly causing the disorder or it is facilitating the disorder. And we will revisit that in future episodes. So I'd mentioned a moment ago, let's define insulin resistance, a definition that is very important for you to remember. As you hear more and more people talking about this, it's very common that I hear people describing it or defining it incorrectly. Let's be precise. Insulin resistance is a disorder with really 2 parts. I like to invoke the analogy where insulin resistance is like a coin. If I were holding a coin in my hand and I say, this coin is insulin resistance, well, the coin has two sides. So too does insulin resistance. One part of insulin resistance is the actual resistance to the signal of insulin. Insulin is a peptide hormone made from the beta cells of the pancreas. You know that. And as it circulates in the blood, it will come and bind on receptors of every single cell of the body. That's one of the reasons insulin is so unique. As a peptide hormone, it is that every single cell of the body, from brain cells to bone cells, from lung cells to liver cells, and every cell in between, they all have insulin receptors. And so the receptor is essentially a doorway that is built for insulin to come and knock on. And insulin will knock on every door of every cell. So this is the insulin resistance part of it, though, where some of these cells aren't responding to insulin anymore as well as they used to. They've become resistant to that knock. So once upon a time, insulin would come and knock on the door of the cell, let's say the liver cell, and the door, if you will, would open right up and liver would respond appropriately. It would do what insulin asked it to do. However, over time, due to insults that we will talk about next episode, the knock falls on deaf ears. And the liver cell doesn't open the door all the time, or maybe it'll open at a crack. It doesn't actually do everything insulin wants it to do. That is the resistance part of insulin resistance. Now, please notice the deliberate use of language here. Not every cell becomes insulin resistant. This is not a universal phenomenon within the body. Some cells of the body fail to respond to insulin as effectively as they used to, or as sensitively as the response that you would expect. Now, we can flip that coin over because there's another aspect of insulin resistance, and this is the part that is so totally overlooked. And that is that in every instance of insulin resistance, with one exception that we'll talk about at a future classroom, insulin levels will also be elevated in the blood. So if we are now going from the level of the cell to the level of the whole body, at the cell there was this selective insulin resistance. At the whole body level, this is manifested as an elevated insulin level. Insulin resistance and hyperinsulinemia, which is the technical term for elevated blood insulin, are inseparable. They will always occur together, just like two sides of a coin. You can't get rid of one side. They're always going to be part of that coin. So too is insulin resistance and hyperinsulinemia. Now, that hyperinsulinemia part is relevant because remember, there are some cells that still respond to insulin as well as they used to, as well as they ever did. They're still insulin sensitive. So you have a handful of cells that are insulin resistant. So even though insulin levels are elevated, they're not responding that well to it. And so it generally is just a muted response anyway. However, the cells that are as insulin sensitive as ever are now overstimulated. There's too much response to the insulin because there's too much insulin relative to normal, healthy, insulin sensitive levels. All right, so that is insulin resistance. Some cells aren't responding to insulin anymore, and at the whole body level, blood insulin levels are higher than they should be. All right, now let's move on to the second part of how we can define metabolic health. As you'll recall, the first way of defining metabolic health is through the lens of metabolic syndrome. The alternative, or an additional method of defining metabolic health, is looking at it as a problem of metabolic flexibility. You might have heard this term too. I'm even a little surprised at how often it's invoked. I actually, just as a point of interest, remember when that first manuscript coming out of the University of Pittsburgh was first published that identified and elaborated this process or this phenomenon in people referred to as metabolic inflexibility. So metabolic flexibility, let's start with that definition first. Metabolic flexibility is the ability of the body to shift very readily between the two primary fuel sources. Now, the cells of the body actually have several fuel sources, but the primary fuel sources are fats and glucose. So at any moment, the body is either primarily fat burning or it's a mix of fat burning and, if you will, sugar burning. or blood sugar or blood glucose to be more precise. I'll just say sugar burning. It just has a good ring to it. So at any moment, that is the primary source of fuel for the body. And it shifts. There are times when the body is primarily fat burning, and there are other times when the body is primarily sugar burning. For example, if you were to eat a mixed macronutrient meal, it has carbs and fats and proteins. Because of the carbs, most especially, you should expect that if you were measuring fuel use in the body would shift primarily to sugar burning. Of course, that would be even more the case if you just ate pure carb. The body would heavily shift to sugar burning. Now give the body 6 hours or so, get into a fasted state, and you should shift over quite substantially to fat burning. So the body will shift. That would be a healthy response. When you're eating food, after that period of time that you've eaten in that postprandial state or the post-eating state, you would shift to sugar burning. Give your body a couple hours or wake up the next day and you'll be in fat burning mode. That is metabolic flexibility. What this manuscript noted, that first identified metabolic inflexibility, is that there were some people who, even when they were in what should be a fasted state, they weren't transitioning out of sugar burning. They were staying in that sugar burning state, not entering into the fat burning state, even though the metabolic situation had changed. They hadn't been eating. They're fasted. It had been the same number of hours, whereas other study subjects had already gone to fat burning. They were still stuck primarily in sugar burning. In other words, their metabolism was inflexible. It had become rigid. The gears of the metabolic engine had become gummed up and stuck, if you will. Now, why? Of course, that's the next question. Now that you understand what metabolic inflexibility is, it is, in fact, the why of it is answered once again by invoking insulin resistance, or in this case, to be very precise, just elevated insulin. Insulin is, in fact, the director of which fuel is going to be used. If insulin is elevated, the body is obligatorily in sugar burning mode. If insulin is reduced, if insulin is low, then the body goes to fat burning mode. That is the single most important variable, or the dictator, in which fuel is going to be used. It's all about insulin. And again, to say that again, low insulin leads to fat burning. Elevated insulin leads to sugar burning. Now, let's come back to those people that were published in this report that were metabolically inflexible. Can you see why they might be stuck in sugar burning mode? Even when it had been hours since they'd eaten and others had long since moved into the state of fat burning, why were those people stuck in sugar burning? If elevated insulin is determining fuel use, elevated insulin, in fact, in this case, was the cause. These are people who are insulin resistant. And as you'll recall, one of the features of insulin resistance is elevated, indeed chronically elevated, blood insulin. Insulin is just staying too high all the time. That is such an important point, and one we will talk about more next week and in future episodes as well. But that is, to sum it up, that additional way of defining or considering metabolic health, looking at it as a problem of metabolic flexibility. And then you knowing now and remembering that metabolic inflexibility is really a manifestation, once again, just like the metabolic syndrome is, of insulin resistance. Now, one interesting tidbit from this, and an interesting aspect of metabolism, is that the longer insulin is reduced and the body is in fat burning, the more the body begins to burn more fat than it needs in order to meet its metabolic needs. Specifically, if we look at the liver, if insulin has been reduced for a substantial period of time, the liver, like many cells of the body, is primarily burning fat for fuel. It's in fat burning mode. And in fact, the fat burning goes on so much that because of the low insulin, the liver, in a way, can't stop burning fat. And normally, a cell will burn as much energy as it needs ATP. I'm getting a little bit off topic here, but or to say that another way, the cell will burn as much energy as it needs to do work. So the cell has a certain work demand, and it will burn enough energy to meet that demand. But if insulin is low for an extended period of time, the body, the liver in particular, continues to burn so much fat that it starts to burn more than it needs to meet its own energetic needs. And that excess is essentially what becomes ketones. Now, my point in bringing that kind of complicated description and introduction to ketones up is only that can become a bit of a surrogate marker. If you are, with regards to your metabolic flexibility or metabolic health, if you have fasted for, let's say, 16 hours and you have a way of measuring your ketones and you find that your blood ketone levels are still really low or undetectable, that suggests that you have high insulin levels, because insulin would stop. If insulin is high, it would stop the fat burning, which would stop the production of ketones, a process that is called ketogenesis. Insulin inhibits ketogenesis. And so if you've entered what should be a fasted state, but your insulin is still sufficiently high to inhibit ketogenesis, so your ketones are low, you have poor metabolic flexibility, or in other words, you are metabolically inflexible. In contrast, if you've fasted for about 16 or so hours, certainly this would be the case with even longer fasts, and you do see that you have entered into a higher level of ketones, whether you're measuring it in your breath or your urine or your blood with a finger stick, then you can be pretty confident that you have good metabolic flexibility, that in this fasted state you had shifted to fat burning, and to say that all another way, you'd have good confidence that you have good insulin sensitivity. Now, the final point that I want to make in this first lesson, talking about insulin resistance, and again, the other lessons in the metabolic classroom this month, the next few episodes will also talk about insulin resistance in different ways, including the causes and consequence. But the last part of the lesson I want to discuss today is just to revisit this idea of how common the problem is. Why is it that insulin resistance has become the single most common health problem worldwide? There are two things that I want to touch on. The first is that our general medical or biomedical view and approach, and the clinical approach to insulin resistance, has actually inadvertently made the problem worse. So in this case, we've sort of selectively looked at certain aspects of the science surrounding insulin resistance and unwittingly accelerated the problem. Now, that's a kind of leading way of describing it, but when most medically trained individuals, or average individuals as well, who have no formal medical training, hear the term insulin resistance, or even when they just hear the word insulin, they immediately think of one thing. In fact, I'm curious, what's the one thing you would think of? When you hear the word insulin, you think of glucose, you think of diabetes. Every time. In fact, just as a point of interest, you'll notice over my shoulder, for those of you that are watching, I have a copy of my book, Why We Get Sick. That book is, as a shameless plug, all about insulin resistance, including everything we're talking about this month. Why didn't I call it Insulin Resistance, Why It Matters, and What to Do About It? Because I knew nobody would buy it. They would immediately look at that title and just assume this was a book about diabetes, and they would think, well, I don't have diabetes, so I don't care. That's not the case, but that is partly why the problem has become so prevalent. It's that we look at insulin resistance as a glucose problem. But earlier in my description and my definition of insulin resistance, what did I say was elevated? Did I say that the glucose is elevated in insulin resistance? No, I didn't. I said that the insulin is elevated in insulin resistance, and that therein lies the problem. That insulin resistance, also known as prediabetes, is a state where insulin levels are higher by necessity because insulin isn't working very well, and it also is elevated insulin is both cause and consequence, and we'll revisit that next week. But elevated insulin is a cardinal feature of insulin resistance. The body has to work harder, insulin has to work harder and higher in order to keep glucose levels in check. But it is capable of keeping glucose levels in check. And so you have an individual who may be manifesting year over year as they come into their clinic for their annual visit with various signs and symptoms of insulin resistance, like, for example, all of the features save the high glucose, of the metabolic syndrome. They have higher blood pressure, they have dyslipidemia, they have elevated waist circumference. And the clinician is only measuring the glucose, which is coming up as normal every time. And so they say everything's fine. However, if they were to expand their view of the problem to include insulin as a marker, they would find that insulin levels can be elevated up to 20 years before glucose levels ever start to change. So as I'm pantomiming this out for those that are watching or just those that are listening, and I'll explain it, the insulin levels are going up higher and higher and higher over the years. It is the canary in the coal mine, or the early warning that something is wrong. But throughout all of this time, as insulin has to work higher and harder to keep the glucose normal, glucose is indeed staying in a normal level. And thus, our glucose-centric paradigm, or glucose-obsessed view of metabolic health, misses the problem. Because as far as glucose is concerned, everything is fine. If we had, rather than a glucose-centric paradigm, an insulin-centric perspective, we would have detected the problem at its earliest stages. Remember, that is the early warning system that we want to look for. We want to have our antenna focused more on insulin as a marker of insulin resistance than glucose. Not only has our failure to focus on insulin resulted in our inability to diagnose the problem as early as we could, it has also inadvertently resulted in therapeutic interventions that make the problem worse. For example, if you have a person who now is struggling with their glucose levels, they now actually have high glucose, this type 2 diabetic now, that has insulin resistance that has gone to the point where insulin has gotten really high to try to control the glucose. But now even that elevated insulin, which may be 4 or 5 times higher than it used to be, is no longer sufficient to keep the glucose in check. Now the glucose starts to climb. Then it sets off the radar. It gets pinged on the clinician's perspective. And then they say, okay, we have to lower that glucose. And do you know what lowers glucose? Insulin. And so unfortunately, what they will do is take this person who already has high insulin and give them more insulin by either giving them just direct insulin injections through insulin therapy, or giving them these oral medications called sulfonylureas, which is a drug that will actually force the pancreas to make more insulin. So they push the insulin up even higher, and it does lower the glucose. So the clinician feels better about that, but who does not feel better is the patient. Those interventions that increase insulin in order to control glucose make the insulin resistance worse, and all of the chronic diseases that we're going to discuss in future episodes also get worse, including heart disease, Alzheimer's disease, cancers, and ultimately weight gain and death. Because insulin resistance is the key problem. It's not the elevated glucose. So that's one reason why insulin resistance has become so common, because we look at it incorrectly. And then lastly, it's simply just our lifestyle. And as we'll discuss more next time, talking about the causes, you'll see that we've created this perfect metabolic storm where we have a host of variables specifically working against us. Specifically, that is our dietary habits and our sleep habits. With diet, the food we eat and how frequently we eat it is exacerbating or triggering in the first place the insulin resistance. And this whole problem is compounded by things like poor sleep in particular. And again, as I mentioned, we will revisit those primary and even secondary causes, and I'll outline those in an immediate upcoming episode to understand the origins of insulin resistance. And then, but again, that helps us understand why the problem has become so substantial. Okay. You guys, thank you so much for listening. I hope you found this insightful, that you can recall and share with friends or loved ones who you suspect may be suffering from insulin resistance. Maybe just as a concluding thought, let me just briefly leave you with an idea of how you might know whether you have insulin resistance. I'd already mentioned the one where you could look at your ketone levels after about a 16 or so hour fast, but also you can just look, or let alone the symptoms of the problems of the metabolic syndrome. If you've been told you have high blood pressure, that's very likely a sign of insulin resistance. But also your skin. One thing you can look at is your skin. Not everyone manifests with this, but particularly around the ring of the neck, the collar level of the neck, two things to look for. One is acanthosis nigricans, which is when the texture and color of the skin changes. Now, due to inherent differences in complexion, the darkening of the skin might not be noticeable if someone has a darker complexion already, but even still, you'll be able to see and feel this kind of crinkled tissue paper texture to the skin. That's the acanthosis nigricans. And a second one that can come with it or be on its own is skin tags. Skin tags are these little kind of mushroom-like stalks of skin. It's not a big kind of rounded hill. It is like a little column that is sticking straight up, albeit very small. You know what I'm talking about. You've seen them. Skin tags and acanthosis nigricans are both essentially proof positive of insulin resistance. So you have a little homework in that regard, just to try to understand where you are, or your loved one, the person you're thinking of perhaps, with where they are with regards to their insulin resistance status. And with that, the lesson's over. If there's any questions or comments, I'm glad to get to them.